Hi, this is Nigel from Suntrap Solar Hot Water. Today we're going to have a quick look at a couple of hot water systems that are solar and incorporate a wetback. Now we've got systems 1, 2 and 4 are integrated rooftop systems that run horizontal on your roof and don't require a pump to function properly. We do have a pump down in this one, but we'll get to that. System number 3 is a mains pressure split system with a wetback that has a collector on the roof that goes direct to the tank and has a wetback coil in the tank and to run with the fire. So we'll give you a little talk about each type of system and hopefully give you a bit of an understanding. Now, this first system here is plumbed up as low pressure. The reason why it's low pressure is because it has an open vent. If you have too much pressure, you'll have the water shooting out the top. If you had a valve in there, like a mains pressure system does, it would hold it in there. But unfortunately, when you have a direct wetback connections, it means the water in the tank is running through your fire and back to the tank. It needs to be open vented. Somewhere along that line, it has to be open vented. When you do that, your cold feed needs a pressure reducing valve, or you need a heater tank to supply your tank with water. Now this system works really, really well because usually in any hot water cylinder, whether it's a vertical cylinder, it's horizontal, whether it's a vertical cylinder or a horizontal cylinder, you'll get a stratosphere with really hot water across the top, medium water in the bottom, and then really cold water, medium water across the middle and really cold water on the bottom. When you've got the wetback going direct in there, the whole tank heats up really evenly, and you won't notice. You'll think, hey, the water's 65 degrees, we've lit the fire and the water's only got to 67, but it's heated up all this cold water at the bottom because your temperature sensor will be up in there, so it's reading from the top anyway. So it heats from the bottom, so it heats evenly and it heats it around. The system number 2 is a mains pressure system that we've made before with a heat exchanger inside. Now we've had limited success with this. We have had success and we have had failures. We've had a few learnings here. Now what we designed here was a heat exchanger that can function without a pump. So it's a mains pressure cylinder, exactly the same cylinder as what's here, but it's got the valve in there rather than the open vent. So a temperature pressure relief valve, when the water gets too hot, is designed to open and let some hot water out, which means cold water goes back in and it self-regulates. The unfortunate thing with this is that you can't have this set up like in option 1 with the valve in there and be compliant. So with this system, the hot water comes from the flow in out of the fire here through a heat exchanger, and it open vents up there and back to the fire. So the water within this loop here does not connect with the water in the tank. So the water in the tank stays mains pressure, and this water here stays low pressure and open vented, which is similar to the split system we have here. This is where you have a solar collector on the roof of your house. You have a cylinder inside your house. You have the wetback connected to a closed loop within the cylinder, which stays open vented so the hot water comes up and then drops back through the coil in the cylinder and back to the fire. And then the solar collector is allowed to be connected directly to the tank, so it is the same water in the tank that is connected to the solar collector. It has a little pump here and a controller with a couple of temperature probes, one to the collector and actually has 2 to the tank. And then when the collector gets 8 degrees hotter than the water in the tank, the controller tells the pump to start, it starts the pump, and it circulates around until the water basically equalizes, the collector temperature meets the same temperature as the tank. Now due to the coil here, it doesn't transfer as much heat. It's best to get one of these cylinders with the biggest coil you can possibly find, because with a mains pressure cylinder it's likely to be stainless rather than copper, and therefore you can't well, it's very hard to weld copper to stainless. It needs a stainless coil, and a stainless coil will not transfer heat as well as a copper coil. So the risk you have with this one is the same as with this one, whereas if you've got a wetback that's too big in the fire, you are boiling it out the top without it getting a chance to transfer the heat. So the water in the tank's staying a little bit cold, and it's the same there, but you've still got this boiling water there. It's not functioning exactly as you want. Yeah, it's 50-50 with these. The other option that's pretty popular in Australia at the moment is where you have an integrated system, the same as the sun trap cylinder, with a mains pressure coil that runs through the middle. So the mains pressure comes up, runs through the coil inside there, and comes out, and the whole tank around that coil is open vented and low pressure, so the water that goes through the fire back to the tank is open vented in that. Now with that as well, you could also run a radiator, so when the tank gets up to 80 degrees, say, you can tell the pump to start, and it will pump through the radiator and back to the tank, and that's also an overheat protection. But it also spreads the heat out through your house, so obviously your water's going to be hot enough. Why not continue to use that water to heat the rest of your house? So really good in principle. In reality, I'm not too sure if it works. Our cold feed in, hot out is a 20mm fitting as standard in New Zealand, same with a split system cylinder, and then that main line into the house will have smaller feeds off that for the bathroom and the kitchen. With these systems, the manufacturer can do a 12mm or a 16mm copper coil at 25 metres long, or they can do a 15mm coil at 45 metres long, and they recommend you put a gas burner or a califont on the end of it just to ensure you've got hot water, even so. Which does make sense because you can buy a locally made cylinder, regular one like this, that has the same system as this, but it's a regular cylinder, and that has a 65 metre coil in it, and a 270 litre system. So even with the stainless, here's a 40 metre coil, which isn't really long enough. So we haven't used these systems. Kind of keen to find a guinea pig to give one a go on if someone's willing, but people are willing. But then is it going to work? Is it going to do exactly what you want it to do? And is the water, is that actually going to be long enough to transfer enough heat? I think it probably would work if you make that coil as long as possible. Maybe use the 16mm copper and make it 45 metres to give it a chance. But at least with this one, if you've got 65 degree water, it's going to come out at 65 degrees. With this one, you might have 65 degree water and it's still only going to come out at 40 because it's flowing through and not getting enough time to heat it up. So that's an unknown, so that's a risk. So hope that explains a few things. GoPro, stop recording.